thermodynamic mc delta T, and internal energy delta E is equal to Q plus W. W is equal to P delta V. If the helium gas was acting like an ideal gas, then you could go one step up and make it into a ideal gas equation. PV is equal to nRT. Replace the P with nRT, then your work done will be nRT ln V2 over V1. So if your Q is plus, it's endosemic, minus exosemic. W, if it's plus, work done on the system, minus by the system, and then you need to add up your internal energy. Question, how do you think of one? Right? A gas expands. If you are in vacuum, which means there is no external pressure. You get it? So the plunger has no external force stopping it. So there is no work done. So in vacuum, there is no work done. And how much work is done if expansion against a constant pressure of 0.5, which means 0.5 atmosphere is actually pushing on the plunger. So you have to push out. So if the 0.5 atmosphere pushes the plunger in, it means that much pressure worked on the system. Clear? But if the plunger moves out, that means the pressure inside greater than 0.5 pushed it out. So that's question 2. Any questions on this? It's not this question, it's about the concept. Any question on the concept? Calculate the work done if 50 grams of iron reacts with HCl to produce hydrogen gas in a closed vessel of fixed volume, B and open beaker at 25 degrees Celsius. Can you write that equation? Fe reacting with HCl? Gives you what?
So the Fe2 plus 1 or the Fe3 plus?
That's what you have to decide. Balance it. Iron is reacting with HCl. That means acid is reacting on the metal. What is produced? One part you use for sugar. What is produced? Hydrogen gas. You write that first. Then balance the remaining one. So if you get hydrogen gas, H2, then it becomes, the Fe will become 2 plus.
2 plus.
So this FeCl2. Those of you who don't know how to balance equation, in 1 year's time you'll become a teacher. So when you go to school and you are trying to explain your students how to balance chemical equation. Huh? I don't know, but you know that guilt should be there if you don't know how to do it. You are a chemist. Now your job is to check. Calculate the work done when 50 grams of iron react with HCl to produce hydrogen gas. So, hydrogen gas is the one that is going to do the work. Not Fe and not HCl. It is the gas that is produced is going to do the work. If it is in a fixed volume, then V2 minus V1 will be 0. So work done is 0. If it's in an open beaker, which means the gas will push. So what do you have to find out? Initial volume and
Final.
the change in volume will come out from assuming the hydrogen gas is behaving like a. So will you be able to do that? Yes, no? If 50 grams of iron is used, then you have to find the moles of iron used. And based on that balance equation, you should know the number of moles of hydrogen gas has been produced. And that will give you the value of
N.
N. Got it? So once you know the value of N, you should be able to know how much volume it will push up. Right? That's what I've shown you here. 1:2 is to 1:1. You know the mass of Fe. Divided by the Weimar of Fe. You will get the moles of Fe. That many moles of Fe is equal to moles of H2. Then you go. Right? Now, many of you will then just focus on this question and then write all the answers, which is already on Moodle. I'm not going to give you this question. What you need to pick out from here is that if you are given questions of this nature, you should know that I have to balance the equation. And if one of, you remember I have been saying this, when you have to calculate work done in a chemical reaction, if either the gas is used as a reactant or the gas that is produced as a product. If one of them is there, then you can calculate the work done by the system. Clear? So in this question, can you see we are just writing it to show that hydrogen gas is produced. So if hydrogen gas is produced, then that will be able to do work. So you have to assume that the gas behaves like an ideal
Ideal
gas.
gas.
Look at question number 4. Based on the same concept of question number 3. Right? 1.6 moles of neon gas are heated from 20 to 85.2 degrees Celsius at a constant pressure of 1 atmosphere. Calculate the work done. That means you have to find the volume at 20 and volume at 85.2, assuming that this gas neon behaves like an ideal gas. So you will find Vi at 20 degrees, Vf at 85.2, and if you get the two volumes, you can find the change in volume. Clear? See, in none of the questions I have written that water is doing this much work. I haven't written that. It's always a gas. And the gas always behaves like an
Ideal gas.
Anything hard? Remember in high school it's like revise 20 years paper and one of the questions will come. Again we don't do that because it's too much hard work going and looking up the past year's papers. You just sit down one day in the office, door open only, windows all closed. And on the day our mood is okay, we start thinking. Then we just look at the question, we look at the situation, we make it up. But the concept remains same. So if you understand the concept, it's easy for you to do the problem. And it's less learning. But if you go by the question, then you are making a hell of yourself by going through all the question, not understanding. And you know these questions won't come in the paper. It won't be repeated. But concept, yes. So you understand these two parts? So if you are dealing with a gas, you should know that question can be that there is a balanced equation is required. Then you might have to find the number of moles of the gas produced. And if the gas is behaving like an ideal gas, then you have to find two things. Either the gas, after doing the reaction, will change the pressure, where volume is fixed, or if the pressure is not fixed, then the volume will change. Two things can happen. You fix the volume, so if more gas is produced, the pressure will increase. So your work done formula will then become ln V2 over V1 can also become ln P1 over P2. Yes or no? Remember, because P1 is equal to V2 P2, so V2 over V1 is the same as P1 over P2. So two conditions. If pressure is constant, then volume will change. And if volume is fixed, then pressure will change. Understand? So when you get a question like this, don't start writing. Okay? Read, digest, then write. So question 3, question 4 is similar. Question 5. 1.5 moles of an ideal gas expand reversibly and isothermally from 33.6 liters to 67.2 liters. You know, just to make you confused, use degrees Celsius. You know, in thermodynamics or in chemistry, we don't deal with degrees. Always
Kelvin.
And one more mistake many students make. Delta T, whether it's in degrees Celsius or Kelvin, it's same. Don't do degrees Celsius plus 273. That's wrong. It's Kelvin minus Kelvin or degrees Celsius minus degrees Celsius. Your difference will be same. Don't do the degrees Celsius and then plus 273 to the difference. Don't do that. Okay? So in this case, ideal gas, find the work done, and then when we have to find the entropy formula for an ideal gas is delta S is equal to W over T, and this is W divided by T, so T will cancel, so you get a formula which is similar to this, but T is missing here. So in entropy, the T is missing. Why? Because it's cancelled off. So the formula for entropy is W over T. So if you substitute that into there, then you get your answer. If entropy change is positive, it means the reaction is leading to more arrangement. Right? Remember, I can't say this is spontaneous. Spontaneous will be delta G. But we know if delta S is positive, it is going to be spontaneous. Because spontaneous reaction lead to more disorder. Question number 6. Calculate the entropy change when 100 grams of lead is heated from 300 to 301. For solids and liquids, you are going to use MC delta T over dt, right? So if you do the different integration of that, you get delta S is equal to MC ln T2 over T1. That formula is for solids and liquids. which I'm showing you here. This capital C here means heat capacity.
Specific.
Is it going to be Cp or Cv? For this question, is the heat capacity going to be constant P or constant V? Hmm? Constant volume or constant pressure? Read the question. Calculate the entropy change when 100 grams of lead is heated from 300 Kelvin to 301 Kelvin. Hmm? Constant pressure. When if it's Cp, it means the reaction was done under constant pressure. If it's Cv, then it's done under constant volume. So the entropy change is given there. Please be careful of the units. Joules per gram Kelvin. Sometimes it is joules per mole Kelvin. And you need to be smart enough to know if your specific heat capacity is in joules per mole Kelvin, then your mass here will become moles. That means whatever mass is given, divide by mR to make it into moles, so that the units are the same. Okay, for this one here, calculate the entropy change when 1 moles of ice at normal melting point to form water. This is a phase change. In a phase change, the entropy change is same as enthalpy of fusion divided by temperature. So in this case, this is the amount of heat that is required. Remember, it's kilojoules per mole. So the temperature here is 0 degrees. So change that to Kelvin, you get your answer. Right? So for this much is joules per Kelvin. So for 1 mole you get 22. For 1.9 moles you do your ratio cross multiplication. If 22 is for 1, how much is for 1.9? Cross multiply and you get your answer. Okay? So you be careful of the units to what it means. That means 22 joules in 1 Kelvin change for 1 mole. It is 22. How much is for 1.9 moles? Of course, multiply. In 203, I showed you in a different way. From minus 10 degrees Celsius, you heat that ice all the way up to 120 degrees Celsius. Calculate the total entropy change. So you see, from minus 10, you go all the way to 0. At 0, there is a phase change. Then from 0 to 100, it is heating. Then at 100, there is a phase change. And then from 100 to 120, there is a heating of an ideal gas. So you find entropy for each step, and then you add them up. And that becomes the total entropy change. Right? So the question here is, if you understand the concept, then you just have to apply it to a real situation. The difficulty with our students is that they are finding it hard to understand the natural processes. So when they have to apply the theory, they don't know how to do it. Why? Because you don't look at nature well. Yes or no? Before, people used to walk, they used to see around what's happening, they used to listen around what's happening. Now they got this, what you call? The plug without the wire now. They plug it here and they don't know what's going around themselves. They walk along in their own world. You know the scientists there. Those things are made for people who are mad. You know that they are in their own world. Scientists are not like that. Scientists are observant. That's what you learned in Form 3, isn't it? Year 9. That people who observe a lot are scientists. So when you ask them, yesterday I would have just parked my vehicle at 8 o'clock and stood out and slapped one girl on the face. In the night, full time working, she never saw my car coming. It would have been gone. Was it my fault? It was always the drivers are blamed. All the time the drivers are blamed, just because you were not attentive. Was it my problem that she plugged it into her ear, she couldn't realize? You know these hybrid vehicles that are all coming into this country was rejected in Japan. Why? Because it doesn't make noise. And elderly people, when they come to the crossing, they can't hear that a car is coming. And that was causing a lot of problem. That the car, when approaching the crossing, should make at least some noise. And because these hybrid cars, basically when they come to a giant stop, then everything stops there. So no sound. And it was causing a lot of, accidents with elderly people there because it was not making sound. That's all they gave it to other countries. Here, despite knowing the car is not made, they plug it in. I don't know whether it is good or not, but it would be good if you sit in the Nasese bus and that's when you plug this one in so that the driver doesn't have to turn on the radio so loud there, because it's not helpful for other people. They don't have to listen to the big loud music. So you plug it in your ear and then whatever level you want to listen to, it's fine. So you should know where it should be used. Not on the road, not in the classroom, not in the labs, not while you are walking along here. So what is the word they call interpersonal relationship, that part of it when you go for an interview. Like they'll be breaking down questions. So tell us something about yourself, and you will say, my name is this, blah, 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 blah. Then, why did you apply for this position? The second question. So we'll try to look at it how you say, I'm the best for the position, that's it. That's the kind of answers we get from candidates. That position is only for me, I'm the best candidate for this job. How do you know? So that's it. So we really need to know how you answer those questions. The second point is what's your interpersonal relationship with people. Oh, I don't, that when you can see when people are trying to do bullshit, eh? If people are plugged in and they look at you sterilely, you pass by, hi, bye, whatever. You get into a relationship with that. So all these things are meant for you to be helping you. At night when you can't sleep, then you plug it in. And those things are meant. If you happen to be in Asian countries, then you will see in the morning, they'll use their leg to push people inside the train. That's how when you are just standing in the door and you just go in, door closes, then you get in. And your face is onto the glass. Because people from the back will then push you. And you are just sticking onto the glass like this throughout your journey. So you don't know what's going behind you, all you see is, like that when you plug your ear and then you stand there. So that's the kind of environment people are living in, to help them to shorten their journey so that they don't feel that they have been pressed on the door for so long. That's why all these things are made, not for our Pacific people. You ask me how they press, I've experienced that as well. So don't avoid going in the train at 8 o'clock. First 4 cars are meant for women. So never sit in the first 4 cars in Asian countries in the train. That's for women. So all the glass will have mirrors, eh? So while they're in the train, they get dressed up. After the 4th car, then everybody can sit. And there are about 12 cars or 15 cars, which is like 1 kilometer long. So for those countries it is meant, not for our students where during the night they will go up. Remember the worst part is when you pass Brown Street, there is a hostel for FSM students, there is a zebra crossing, and this side. These bloody doctors in our upcoming will never look left or right. They will just come down and straight across. Why? Because they are too egoistic. I'm a doctor. So one of them flew up. Rule applies. You stand and you look left, right, isn't it? Vehicle not coming, then you cross. But you see, majority of them will be inside. And they will be talking to their friends or without looking anywhere, they'll cross. I don't know how they become doctors. Anyway, question number 8. So it's important as a scientist you observe your environment because questions will basically be sourced from the nature. We just apply the theory. Okay, for this reaction, please from your 101 go and learn how to calculate delta H naught. That is H naught reaction is equal to sum of H product minus sum of H reactant. Delta S naught sum of S product minus sum of S reactant. Delta G sum of G product minus sum of G reactant. Do you want me to write it on the board or is that sufficient enough what I am saying? Or do you want me to write it all the formulas on the board? Yes. Then what were you doing in 101? If you want me to write it here, then what were you doing in 101? I'll explain, you should go and look for it. For delta H naught, sum H product minus sum H reactant. S, sum S product minus sum S reactant. Delta G, sum G product minus sum G reactant. What does it mean? All three are state function. Because final minus initial. Then delta G is equal to delta H minus T delta S. Give free energy. Then we have delta G is equal to minus RTLNK. And you know what is equilibrium constant? Equilibrium constant means when the reaction comes into a state where the forward and the backward rate become same. That means the concentration of the product and reactant are in dynamic equilibrium. I won't say same. Dynamic equilibrium. So what you need to do is using this Gibbs equation, find the value of delta G naught. Then take this and put it into delta G naught into minus RT ln K. Then make K the subject of the formula and find the value. Please learn how to use your calculator to change from ln K to K. Don't ask me in the test, Ma'am, sir, how is this done? I don't know. I know FX82 where you shift ln. So please learn how to use the calculator while you are doing your tutorial. Don't call me in the exam and say, sir, how you applied this? I don't know. Question 9. This is the bomb calorimeter. In the bomb calorimeter, overall this is what we do. There is a cup made up of copper which needs to be cleaned thoroughly so that it is shiny. Then you weigh the cup and then in the weight cup you have to weigh your sample. Your sample has to be dry. No water in it. It should be completely dry. Then you weigh your sample in the cup. After that, there is a holder on which you have to get a wire thread, cotton thread. You have to place it in such a way that the thread is touching the sample, and then you connect the thread to two electrical wires that are like this, so you push it in. So that the thread is touching the two wires there, and then the other end is into the sample. So you have to put your wire down and then put the sample on top. Right? Then you connect that to the machine and then into a bomb. It's a constant volume, thick, heavy cup, which you tighten it up. Then you need to take it to a compressor where you need to add 300 kilopascals of oxygen gas into the chamber. Once it reaches 300, then that's fine. That means we have enough oxygen inside. Then after that, you place it into the machine and then ignite. So when we press the button ignite, the two wires that I told you in which the cotton thread was, it will light up. And then the cotton thread will burn and come to your sample, and because you've got a lot of oxygen, the whole sample will burn. So when it burns, it will give off heat. So the more sample you have, the more heat it will give off. Clear? So the way we do the calculation is this. Heat released by the amount of sample you have used is equals to heat capacity times delta T. So what they do, the machine will basically measure the change in temperature of that thick steel cup. So that is this part, right? And the mass of that steel cup is known, which is already programmed into the computer. So the mass of that becomes your heat capacity. So the amount of heat that is released by a burning sample is taken up by the cup. So that's what it says, heat capacity times delta T. So what we see here is how much heat is being released by the burning sample. The problem is when you go to the machine will not show you all this. The machine will just give you the final answer. Because the chip that is programmed in the machine will do all the calculation for you. So you get the final answer. So if you don't know the basic, then what you will explain? You will just look at the final answer and you go away without knowing what you have to say. That is why I am showing it here. That the heat capacity of the bomb will be the amount of heat it will take once the sample burns. So this multiplied by this will give you the amount of heat released by the burning sample. If I divide that by the mass of the sample, then my answer will come to joules per gram. Otherwise it would be this much heat was released by 1.54 grams. If I divide this by 1.54, then I get my answer is joules per gram. Understand? You know, if someone eats 10 lamb chops and one eats one, oh, you know, you two are eating lamb chops. Lot of calories. The one who is eating more will burn off more or take in more calories. The one that is eating less will take in less. But the question is, why did you say this? It is because we know per gram, in terms of other meat, this one is going to give you more energy. Clear? So if you have to compare, then it has to be per gram. Understand? You know, it would have been nice if you understand this, and if those of you who are becoming teachers, when you go to school, you explain it like this. So that the incoming student will basically understand this way. But unfortunately, the teachers are not in my class. Majority of them don't come to my tutorial. Why? Because they don't do this course. They do CH 101, 102, 201, 204, 311, 3012, and out they go. So the two hard courses, 203, 301, which is taken by me, they don't take it. They become a graduate. So when they go into high school, when the topic on thermodynamics come in, Go read the notes. That's where the problem. In order to become a chemistry teacher, you need to take all the chemistry courses, isn't it? So those ones who are smart, who don't want to become teachers, they will do all the courses in chemistry. Even though in BSc, GCED, they never end up in teaching. Right? Because once you do 203 and 301, you are good enough to be outside of high school. But if you go in there, then you are a very good teacher. Because you will be able to explain when people will come with questions like, how do you do this experiment, how would you find this, what is the identity of this? Because in 102 we show you classical method. In 301 we show you instrumental method. Like for example, unsaturation is detected which way? Unsaturation in organic compound, how do you detect? 102. How do you know if this is an alkene or alkane? Bromine test. Decolorization of bromine water means unsaturation. Remember? You're giving me a very good indication you know what you are doing. When you come to 301, I'm not going to ask you bromine test. Run the IR. Infrared analysis will tell me if the peak is appearing here, it's unsaturation. If it doesn't, it's saturated. So if you don't know about your classical method now, in second year, what are you going to tell your students? That's why when students come in, they say organic chemistry is hard. It's not hard. It's simple, people don't understand. Then remember, you can't just do the course, pass, forget. This is your life. You are going to be a chemist. And chemists can't just come in and forget. You know, when we stand up in front, we have to know all your chemistry. We have done everything from you. The honors is on you, how you remember it. Okay, question number 10 is thermodynamics. This is a coffee cup calorimetry. And the other tutorial that is going to be answered, which is in tutorial sheet. Oh, I think it's 3 as well, but that will be looking at the stuff that we have done on Monday. So that will be discussed in next week's class. Okay? If I have to pick up questions, I'll pick up questions from your 102, 201, 101, and then put the 203 concept there. If you don't know how to balance equation, it's not my problem. If you don't know what kind of reactions happen in organic chemistry, it's not my problem because all of you have done 102. Right? When you have spare time, go back and read up those notes because you have already covered. Don't plug it in your ear and then relax your mind with music. This is not the time to relax your mind now. That will happen after 3 years when you get your degree. Okay? I need my sheet.